Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I am Ginny Tomei, and I am joined by Dr. Elena Hyde. Hi, Elena.
Muting myself now. Hello, hello.
Hello. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. UT, if that is more your speed. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. Head over to yorku.ca/science/observatory and follow the links to OPV, that's online public viewing, to join the chat. For any questions or comments you have about our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on socials. We have various handles on Twitter or X. It's at York Observatory. On Instagram, it is at York U Observatory. And on Facebook, it is Allan I. Carswell OBS. All of our programs are free, but we don't say no to donations. Kindly head over to our website at yorku.ca/science/observatory if you are so inclined. We'll be monitoring the chat room for questions and posting content. The current weather is clear. So,
Hooray!
huzzah! The telescope is open.
Indeed, very, very fun times.
How are you doing, Elena?
Oh, I am doing well. I'm doing much better. Of course, I think the clear weather is absolutely helping. And I will just say, we are looking very much forward to being able to capture some live images from the 1 meter telescope tonight on OPV. So if you're watching this on YouTube live, you have a bit of a treat in store. Unfortunately, one of the things we cannot currently target is that wonderful comet Pons Brooks, and I just thought it would be fun at the start of the show to mention it is setting basically right now. Um, and it's very, very low in the west in Toronto. So if you're watching the sun go down, you have a chance to get it with a camera, perhaps. But it's very hard for large telescopes to point quite that low on the horizon.
Mm-hmm. Although in about 4 minutes, there'll be
Indeed.
something exciting overhead.
Yes, and we're looking forward to that as well. So, even if you don't have a clear view to the west, there's something reasonably bright that should be passing overhead, as you say, in about 4 minutes. So by my watch, it comes up around 9:07, and it's the Tiangong space station. And I might be saying that a little bit wrong, but this is the Chinese space station, and it's a permanently crewed space station operated by China. And I don't know if we talk about this station enough on this show, but since it's literally going overhead, our observatory crew will probably try to just put up stellarium at 9:07 to show it traveling across the sky real time. It's fairly bright. I have it down as magnitude. Oh shoot, I lost it there for a second, but it was fairly bright this evening. I had the magnitude a minute ago, but I believe it's if not Jupiter bright, at least Saturn bright.
It's fairly bright.
Yeah. Something like magnitude 2, I thought, but I've actually just clicked it away. So a little bit of a do it at home. Check the magnitude. If anybody is interested in following along. Of course, it is going to be moving across the sky, so this is going to go much, much faster than things like stars or planets or asteroids, things that we usually follow with the telescope. So we won't be able to really point the 1 meter at it per se. But it should be pretty fun to watch if you were out looking at the sky right now or in 2 minutes, 2 minutes and counting.
Yes. Satellites, space stations, and the like tend to travel across the sky from one side to the other in a matter of minutes.
Yes, and they do go quite fast, and of course, the lovely large solar panels help a lot with the brightness and reflecting light from the sun back to Earth to make them reasonably easy to see. That said, we're not actually short of satellites in the sky anymore, but this is a nice bright one.
Yes. All right. Shall we jump into our This Week in Space and Astronomy history?
Well, I'm of two minds because we're so close to this space station actually coming up. I thought maybe we talk about space stations for 1 minute
Let's
and
do it.
see if Tiangong does if we are able to bring that up, because of course this space station is a pretty interesting comparison, and there's a lot of talk about of course, private space stations and the Lunar Gateway and settlements on the moon. But we don't talk quite as much about space stations from other countries, and there's not a lot of them. Historically, of course, there have been space stations from Russia. We have the International Space Station, but Tiangong Space Station is, China's first long-term space station, and it's actually part of I believe the third level or third step of their crewed space program. So it's an interesting vehicle in and of itself. I mean, obviously, also in low Earth orbit, also going around, getting some protection from that upper magnetic field. Um, but it's an interesting comparison. It's obviously smaller than the ISS, but they do have some interesting labs and modules, and it's interesting to see it done in a bit of a different way.
I have to admit, I don't know very much about it.
Well, it's similar actually in a lot of ways to the ISS. It does have solar panels. Of course, they do not have the Canada arm, so we can claim that for our own. Of course, Canada's. If anyone's curious, Canada arm is arguably sort of Canada's gateway into space. It's one of the things we're known for. It's one of the I think really big drivers of possibly being able to have the lunar gateway. The Tiangong space station has its own robotic arm, so obviously not as good, but don't tell them I said that.
You just
Um,
broadcasted, Elena.
I know. Oops. But they actually have it, fashioned in a very similar way because, of course, right now we're on Canada Arm 2 going on to Canada Arm 3. So Canada Arm 1 was pretty much the inspiration for the Tiangong station arm, and they have five robotic arms. The longest one is a 10-meter Canadian style robotic arm, and it's called Chin Arm or Chinarm. It's CHINARM. So I'm not sure if it's China Erm or. Anyways, you can argue with us in the comments about how exactly to say the robotic arm name, but it's on the core module and it's the longest one. And so this has the most ability to help deploy things, assist in cargo transfer, retrieve experiments, launch microsatellites, a lot of the same stuff that the Canadarm does.
Mhm.
And this station was, by all accounts, it seems to have been done very, very quickly, which is another thing I've seen in some Chinese satellite launches and things like that. They seem to have a very quick sort of start to launch pathway.
Mhm.
once
Mhm.
once they decide they're going to do it, up it goes. So it seems like it was quite fast to me. And of course, this is part of a much longer ongoing program, and it started back in the construction of this started in 2021, which is not that long ago.
No, not at all.
So this is a pretty fun I don't know, contrast and a wonderful science case. It has a lot of high energy experiments. It's got radiation detection, lots of different types of experiments for long-term human spaceflight and all that good stuff. So did everybody see it go by? um, so blinking you missed it. It's just now setting under the eastern horizon.
All right.
So, anyways, that's Tiangong, and that's my story about how space stations are cool, and it is pretty fun to watch them run around. So, I suppose this actually gets us to this week in space and astronomy history because I'm already talking about launching things and how some things are faster than others.
Yeah, let's do it.
So, speaking of launches, this day in history, plus 2 days, minus many years, several years, 1990, April 24th, a very different thing was launched. This was the Hubble Space Telescope deployment. It was not particularly fast, but it could have been a little slower. So, as many of you probably know, Hubble Space Telescope famously launched in 1990, and it was a telescope that was under development for many years. And after launch, it was not exactly 100%. So they did have to go
Yeah.
back and
It needed some glasses.
it did, but it was still the start of a real game changer moment for science. And so
For sure.
the launch was this day in history, 1990, and it was launched above aboard Space Shuttle Discovery. So this is the what we're now, I guess, referring to as the old method of launching things into space, back when we
Hmm.
had space shuttles, because we don't have those anymore. But Space Shuttle Discovery, and this was NASA's Hubble Space Telescope, and it has 3 decades and counting, I suppose, of absolutely beautiful images, amazing exploration. We have discovered so much thanks to Hubble. It has been absolutely worth the trouble to go and fix it. This was STS 31, so shuttle mission 31, and the duration for actually getting it into orbit was 5 days. Of course, the time it took to fix it was a little bit longer than that. But when they first launched it in 1990, the STS 31 space shuttle mission, they got some lovely pictures of the space shuttle suspended above the shuttle Discovery's cargo bay. And you have to remember, these shuttles had these amazing cargo bays that opened, and somewhere there's probably still toys of this that you can find. You could open up and you could put things in. And of course, it had the Canadian-built remote manipulator system ARM, Canada ARM, which was controlled from inside the cabin by the astronaut crew members. So back to Canada ARM, yes. 1990, and of course, this held this quite hefty telescope into position, so it had to be go through a whole long laundry list of pre-deployment procedures, which is it has to get its solar panels in order, has to put its antenna out. So it was in this little tiny cylinder and it had to kind of unfold basically. This mission had Lauren J. Shriver, Charles Bolden Jr., who I believe later became a NASA administrator, and it had mission specialist Stephen Hawley, Bruce McCandless, sorry, and Catherine D. Sullivan, who also I think became later a NASA administrator. So it was a pretty interesting mission. Of course, this was the life work of Spitzer, Lyman Spitzer, who was an astrophysicist who outlined a proposal for a large space telescope back in 1946. So let me just put those numbers really quickly next to everybody's heads. 1946, Lyman Spitzer says we need this telescope, and it's launched in 1990. And if we're just comparing that really quick back to Tiangong, so they started in 2021, I think I said,
Yeah.
and this is 2024. So this was a very different time in space exploration, and a really interesting deployment in a lot of ways. Of course, this was one of the sort of the final things that Spitzer got to do. And it's interesting that this one's called Hubble because there is a Spitzer Space Telescope. But anyways, um, the deployment started off pretty well, and it wasn't until they actually came back that they found out that there was in fact a bit of a problem. Of course, the long construction cost of this telescope and the sort of both in time and in money was because in 1990 this really had not this kind of large telescope really had not been done before.
Yeah.
And the ground support um, during the launch was very, very different from what we've seen recently with all these private space launches. But yeah, the space shuttle did actually get the Hubble instrument up there, and since then it's had several servicing missions, not just for its initial repair. Within a few weeks of launch, after deployment, they realized there was a problem because they started getting images back, and this was, of course, as you said, basically glasses. The mirror, when they made it, was believed to be one of the most precisely figured optical mirrors ever made. So at the time, this was the best of the best, flattened to I think a few thousand nanometers or something, very, very, very small. But the difference was catastrophic. So it really
Yeah.
made a severe spherical aberration. And this is a kind of aberration that you can get if you have glasses as well. So you might have seen something like this if you've also needed vision correction. Um, and this had to be fixed. It was so bad that they just could not leave it alone. So of course, designing a solution was the next step because it was either abandon this massive project that had taken so much time and so much money, or try to fix it. And I am so, so happy that they fixed it.
Same. I,
Um,
I feel like abandoning it really wasn't an option.
I mean,
Truly.
you could say that, but I mean, there have been so many amazing projects that have gotten so far only to get scrapped, and it's just I'm really, really glad this was not one of them. And of course, the servicing of Hubble has been an ongoing issue. Even after it was corrected. Do we have enough money to send people up to do more servicing? And they've had, gosh, how many servicing missions
I
now?
think it was
Four?
three.
Oh, I think
Three? Four?
there was
I'll
one
look it
in,
up.
there is, I think, no, I think there is four because, um, I seem to remember something 2004, 2005.
Yeah, there are four.
Um, but
Oh,
yeah, that
wait,
was
hold on. What's
because there was one in flown by Atlantis, which was, I believe, one of the last sort of
hold on,
space
there were
shuttle missions.
five.
There are five. Okay.
I
So
think.
which one was
Yes.
Atlantis? Was that four or five?
Uh Atlantis was five.
Oh, okay, good,
May
good.
11th,
Because that's what I was thinking.
2009.
Yeah, so that was the last one, right?
That was 15 years ago.
And they put in new cameras, right? So new observation images, which basically helped, put in a whole new bundle of life into the Hubble, because there's a lot you can do with the cosmic origin spectrograph, for example. And it's a pretty impressive telescope that has done a tremendous amount since 1990. And I just hope we get to continue to look at it for a few more years.
Uh, Fingers crossed.
Fingers and toes, of course. They are planning to deorbit it safely at some point, but the date has been changed several times.
Yes. We're going to
What
get all the science we possibly can out of this thing.
exactly? And right now we don't have anything Hubble like. We have JWST, but having Hubble comparison on JWST fields is, I believe, as many astronomers will tell you, hugely advantageous because
Yeah,
there's different instruments, different wavelength ranges.
exactly.
So maybe we can keep it up there for a few more years.
You mentioned toys.
I did.
There's a Lego set.
No.
There's a Lego set of the Space Shuttle Discovery with the little Canadarm and Hubble hanging from it.
Okay. So I need to make a list for my birthday.
Mm-hmm.
Send that off because I do not have that. But that sounds amazing.
Yeah.
So,
I mean, it was released in 2021. I'm sure this was like, limited edition. It was
oh,
$200 bucks.
so it
Um,
might be a collector. Maybe I don't need it.
entirely possible. I don't know. I just came, you were like, oh, there were pictures. So I was like, ooh, pictures. And one of the things that came up, I was like, is that Lego? It's Lego.
I'm sort of recalling an old like 1995 play school mobile sort of toy,
Nice.
but
Love
this is like
it.
seen somewhere in the background of I don't know, TV advertisements. But yes, if you do come across one of these, I can say the old designs were really really fun and great if you do have kids and you're trying to show them how things work because there's a lot of components that can be sort of put together and played with. So, yay for space telescopes.
Yes, indeed.
Anyway, speaking of space,
Yes, we're going to continue with space. We're going to continue with launching things.
let's keep launching things. Let's do it.
Yes, we're going to launch things, but also on April 24th, but 20 years earlier, 1970. And this was the launch of the Dongfang Hong 1 satellite by the People's Republic of China. I'm sure I'm mispronouncing this because Chinese is hard, man. Um, Anyways, this was China's first satellite. Its name, Dongfanghong, means east is red. And the primary purpose of the satellite was to perform tests of satellite technology and take readings of the ionosphere and the atmosphere. It was part of the Two Bombs, One Satellite program. The bombs being the atomic and later hydrogen bomb and the intercontinental ballistic missile. Okay. Sometimes I choose, sometimes I forget how much rocketry and like space, like going to space, has so much of its roots in like military application. And then I read something like this and I'm like, oh, yeah.
Yeah, 1970, man, that was I mean, I wasn't there, but it was pretty serious.
Yeah. So China tested its first atomic bomb and first hydrogen bomb in 1964 and 1967 respectively, and then they combined the atomic bomb with surface to surface missile in 1966. Uh, and then they they launched their first satellite in
Oh,
19
that's yeah, as advertised, two bombs and one satellite.
two
Boy,
bombs and one satellite.
that is the wrong ratio.
I agree. How about all satellites, no bombs?
Yes.
Um,
I second this motion. We've put it to a
yes.
vote.
So the final push to launch started April 1st of 1970 when the satellite and rocket arrived at Jiuquan Satellite Launch Center, which is located and along the border. So it's like partially in Inner Mongolia and partially in Gansu province. The premier, Zhou Enlai, called a special meeting for final readiness review on April 2nd, and he also wanted guarantees that the satellite would transmit the march entitled The East is Red from orbit. The satellite
Mm.
launched at 9:35 p.m. local time, and a rocket expert, Shen Jianan, recounted that, quote, as soon as I saw the liftoff on the TV screen inside the bunker, I ran outside. I could only see the beautiful rocket lighting up the night sky and streaking towards the southeast. I ran back inside to listen to the transmissions. Broadcasting on the speaker were status reports like capturing target, nominal tracking, nominal flight, nominal second and third stage separation, end quote. China became the fifth nation after the Soviet Union, the United States, France, and Japan to launch satellites from their own facilities. And at 9:50 p.m., the National Broadcasting Bureau announced that East is Red was indeed transmitting loud and clear.
My goodness. As you say, as we said before, exciting times. But yes, this would have been both politically and scientifically very important at the time.
Indeed.
Although with it literally being called East is Red, I don't think that there's too much ambiguity there in what they were trying to do there.
No.
I
Um,
suppose speaking of disagreements, I can get to the next item.
yes, let's do it.
All right. So speaking of disagreements, things that were extremely well recorded, extremely large disagreements that fortunately did not require bombs. We're going to go to 1920. So I'm going back even more, and we're going to the Shapley-Curtis debate, or the Great Debate. This was April 26th, so that's 4 days from now, and back in 1920, so we're going back. The Shapley-Curtis debate was as about I suppose an unfriendly debate as you can have without bombs. But it was, of course, it was called the Great Debate to argue the scale of the universe, and this was something that was a pretty darn big deal. And so, of course, the Great Debate was something that was publicized. It was something that they actually did have an official debate hall. It took place at the Baird Auditorium of the Smithsonian Museum of Natural History in Washington, D.C., USA. And it basically was just a real straight up debate. They had two scientists, and they had Harlow Shapley and Herbert Doust Curtis, which is the Shapley Curtis debate. And this was, as I say, not a particularly friendly debate. The two scientists were well known for disagreeing about pretty much everything. And they wanted to discover, what was the size of the universe. So at the time, we knew about the Milky Way, that our star and our sun was a part of a group of stars, and this group was, the Milky Way galaxy, the galaxy we live in. But that was the extent of the universe for some people, and that included Shapley, I believe. Oh no, Curtis. Curtis was the one. Make sure to get him right. So Curtis held that they were in fact independent galaxies. So this was implying that the little Milky Way galaxy would be one of many galaxies, and Shapley would say that no, they're small and they're on the outskirts of the Milky Way galaxy. So Harlow Shapley was the more established, I believe. He was the older scientist. He was the head of the Harvard College Observatory. He was, very active. Versus Curtis, he was an astronomer, he was a journalist, and he's pretty much famous for this debate. So Curtis contended that the Andromeda, which is actually visible to the naked eye here in the northern hemisphere, the Andromeda galaxy, and I suppose the large and small Magellanic Clouds, if you're in the southern hemisphere, and other these nebulae, as they were called, were actually separate galaxies. And so this would have been away from our own Milky Way. This was also called island universes because the idea that the universe could be so vast was as to have something outside the Milky Way on these incredible scales. It's a pretty weird idea, and of course, showing this would be quite hard because measuring distances in astronomy Well, it's been a problem for a long, long time. So parallax, was fairly recent in 1920. So 1920, we had parallax distances to some stars. But how are you going to get distances other than parallax? And how are you going to determine distances out in the universe? Well, that's where Cepheid variables come into play. And so this, of course, was part of the um, sort of the revolution that was going on at the time. So the debate was held in 1920, and it's worth remembering that the Cepheid variables had actually been around for a while. Henrietta Swan Leavitt, she and her variable stars were, already well documented in 1908. So she actually, substantially laid the groundwork for both this discovery and what is called Hubble's law. And of course, Leavitt, she was a astronomer who started to get a little bit more recognition now. Her nomination of Leavitt for the Nobel Prize was actually halted because of her death, unfortunately, in 1921. So she died a year after this debate. And before she came in, the period luminosity relationship for Cepheid variables wasn't really known, and she was the one who published that. She it was 1903, I believe. She was in the Harvard College Observatory, which we've talked about before on this program, working with other famous folks like Annie Jump Cannon, identifying variable stars, and she published her results in 1908, noting that brighter variables had this longer period. And the period brightness relationship allows you to get distances for these stars. And that means that if you find one of these, you can use them to get distances where you never would have before. And so you can actually find some of these stars in things like the Large and Small Magellanic Cloud or in the Andromeda Galaxy. And this is what happened. So Edwin Hubble in 1924, he actually would go on to establish Cepheid variables in the Andromeda Galaxy, which was then called the Andromeda Nebula, and show that there's no way those variable stars could be in the same area as the Milky Way's variable Cepheid stars. So they must be much, much, much farther away. And so, of course, this was all part of a really interesting time in astronomy. It was, I think, just another case of us realizing how big the universe really is. Of course, the Earth being extremely small. If you're really lucky, you've gotten to walk through maybe a model of our solar system, and you get a little, maybe a 6 or 8 inch sun. You walk and you walk and you walk, and you finally get to Earth, and it's a little tiny, tiny, tiny dot. You walk and you walk and you walk, and that's just the solar system. And so, putting that into perspective with the galaxy is hard enough, but then going one step further and putting our galaxy as a little tiny dot out there in the universe, that's really where this debate, came up. So it proved, the great debate basically, showed that we could finally have a universe that was much, much larger than the Milky Way. So the arguments in this case were Shapley arguing in favor of the Milky Way as the entirety of the universe. So the whole universe, everything that exists is the Milky Way. That's it. And spiral nebulae like Andromeda, they're all just part of the Milky Way. And he used relative sizes. So if Andromeda was not part of the Milky Way, then its distance must be incredibly, incredibly far, 10 to the 8 light years, as a span of distance that astronomers couldn't possibly accept. And a lot of astronomers, and very respected astronomers, were like, "Oh, that makes sense." So it couldn't possibly. It turns out it is actually really far away. um, but that was the argument that he had. He backed up his claims with an observation of a nova in what he called the Andromeda Nebula. It was actually the galaxy, which had briefly outshone the entire nebula, which would seemingly be impossible unless you know what a nova is. So that's so that was another problem. So how could an explosion ever possibly outshine an entire galaxy? Well, one problem: this is not a normal explosion. So this was his argument though, and Curtis had to counter this argument. So Curtis came up and said, "Okay, well, I'm against that. I am contending that Andromeda and several of these other kinds of nebulae that we've seen, they're separate galaxies or island universes, which is a beautiful term. It was actually coined by German philosopher Immanuel Kant, which is, it's a lovely turn of words. And actually, Kant from the 18th century, this he was, a bit of from a bit of an earlier time. He also thought that the spiral nebulae were extragalactic. But Curtis, what he did was he showed that there were more nova in Andromeda than in the Milky Way. So there were more of these explosions in Andromeda than in the whole Milky Way. So why would there be one section of our galaxy um, that had more nova than the rest of our entire galaxy? That wouldn't make sense unless it was, a separate galaxy. So this is leading to Andromeda's support as a separate galaxy with its own age, its own rate of nova occurrences, so it could be different from the Milky Way. And he also noticed a lot of radial velocities of spiral nebulae. So he was able to measure radial velocities that we can do from spectra, and they couldn't possibly be bound to the Milky Way in any kind of normal gravitational model that they knew of at the time. And of course, they had dust lanes, dust clouds, like the Milky Way does. So maybe, Curtis said that finally that if some of these observations were correct, and especially the Pinwheel Galaxy, they could have been wrong about the scale of the universe. So, obviously they were, but for this particular debate, they didn't really know about it, and it was a very interesting one at the time because this cosmological showdown, as it were, uh, really came into place. I think it's one of the better astronomy showmanship um, examples that I can think of, because this all happened a year earlier, 1919, when George Hale, of the head of Mount Wilson Observatory, you might have heard of Hale-Bopp, um, Comet Hale-Bopp. We talking about comets earlier today, but
Mhm.
anyways, he proposed a debate to consider the merits of island universes or some other solution. And they're like, oh, debate has it's been done to death. Audiences wouldn't care, and they basically framed it as uh, you know a gentlemanly discussion, and they had an audience of academics, members of the public, and this might be apropos of nothing, but there are some news accounts that say Albert Einstein was in the audience. So I don't know if that's true, but I did read a couple accounts of this debate that actually said that Einstein was there. So we have some evidence, but it was a big issue of the time, and the final sort of the final call on the debate was Curtis probably declared the winner. But in the end, there's not great documentation of it because they didn't, for some reason, I guess they didn't take notes, or the transcripts were lost. But both scientists did get through the debate okay. No bombs were involved. They both went on to good positions. Shapley went to Harvard College Observatory, and Curtis went to Allan Observatory. And of course, very, very shortly after, we had Edwin Hubble using the Cepheid variable relationship of Henrietta Swan Leavitt to, of course, make those measurements and show just how far away the Andromeda was outside the Milky Way, and that was it. The scale of the universe needed to be expanded by a lot. There is a lot of not things out there, and it's just, distance between galaxies is extreme. And the distance
Yes.
measurement to Andromeda, um, really, I think, it's been said it was the biggest game changer or the biggest scale revolution since, the sun-centered model to the solar system. And I would tend to agree. There have been a few times where we really had to revise our position in the universe, and this was definitely one of them. And the Great Debate um, wasn't maybe the thing, but it was a characteristic of this real turning point in time, where you had Henrietta Swan Leavitt, Cepheid variables. You had the Shapley-Curtis debate. You had the Hubble measurements coming in, and it kind of led to this change in our understanding of the universe. So pretty fun.
Yes. When we realize that space is big, really big, you just won't believe how vastly, hugely, mind bogglingly big it is.
Yeah, there's really no. At some point, you just have to start writing down the zeros and see
Yes.
how far you'll get.
For anyone out there who's interested in learning more about Henrietta Leavitt and the other women from the Harvard Observatory, I recommend The Glass Universe by Davos Sobel. Excellent book.
Oh yes, absolutely, and I very much recommend reading up on the computers at the Harvard College Observatory in general, and the work that
Yes.
these women did. It wasn't just her,
Yeah, no, they're
Philomena
all in there.
Fleming. It's yeah. Oh, that's great. Maybe I should get that book too.
If
I'm
you
working
haven't
on
read
my
it, you should read it. It's really good.
Christmas list. All right.
Okay. So if you haven't been listening since the beginning, you're listening to York Universe. We are broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. For chat, questions, comment, or content, I should say, head over to yorku.ca/science/observatory and follow the links to OPV. Tonight, you're listening to Julie Tomei and Dr. Elena Hyde. We are just about to wrap up. We've got one last item in our history, another launch. And this is of the San Marco 2 satellite. The San Marco program was an Italian satellite launch program that ran between the early 1960s and the late 1980s. The first Italian satellite was launched on December 15th, 1964, making Italy the third country to the fifth country to operate its own satellite. And with the launch of the San Marco 2 satellite on April 26th, 1967, Italy became the third country to launch a satellite with its own crew and facilities. So fifth to operate its own satellite because Canada and the UK had launched from US facilities prior. San Marco program was a collaboration between the Space Research Commission in Italy and NASA. San Marco 1 flew from Wallops Flight Facility, but the rest of the satellites in the program were launched from the San Marco Equatorial Range, which is a platform 5 kilometers off the coast of Kenya. San Marco 2 was the first satellite launched from a sea-based platform and was designed for study of high-altitude air density and its small-scale variations, and to study the equatorial electron density irregularities and uh, ducted radio propagation from 200 kilometers. The spherical shape of the spacecraft was important to the air density experiment in that it provided a constant satellite cross section to the decelerating effects of the air, which simplified the math. Yay,
Yay!
spheres.
Spherical cow returns.
um, and it performed as expected until August 5th, 1967, and re entered on October 14th that same year.
Very fun. And of course, this is one that you also don't hear a lot about because the San Marco program, it just didn't get a lot of, I suppose, a lot of press coverage in North America. Although I think some of their rockets did get launched from the US as well.
Yeah, just the first one. And then all the other ones were from the former oil rig off the coast of Kenya.
Yeah.
Because when you are a former colonial power, you have access to the equator.
Well, and at least they're using the oil rig for something good, maybe.
Yeah, it's better than oil,
Yeah.
honestly.
Um, but yeah, it is a very interesting, an interesting program, and of course, at this time, there were a lot of first rockets being launched. So these smaller rockets seem to have a pretty good launch to exposure rate as well. When I was looking at the San Marco program, it didn't seem like they were getting quite the same number of rockets just flat out exploding. Although maybe maybe they weren't advertising those as well as some of the other rocketry places in the U.S.
Well, I guess when you're partnering with like an organization like NASA on your program, then you get the advantage of like all the knowledge that NASA has gained in
Yeah,
the exploding rockets.
that's true. That's true. And they did have the I think the Scout rockets, wasn't it? The little tiny ones.
Mm-hmm.
So those would have been already pre-exploded before they got into this program.
All right.
Excellent.
All
Well
right.
then, let's round up some reminders and get into some
Let's
news
do
items.
it.
Shall I start us off?
Sure.
All right, so just a little bit of a reminder for anyone interested in the in-person tours this week at the Allan Carswell Observatory. The very first atrium tour out on top of the Arboretum parking garage, not counting the solar events, but this is an evening tour, is actually this Wednesday. So we said it was last Wednesday, but that was before it got cloudy. So we're hoping that the clear weather sticks with us. And just a reminder, if you are going out there in person, the atrium tours do require clear weather. So unlike observatory tours, we can't have you up there if it's too cloudy because we have to keep all the telescopes inside the cage. So this Wednesday after sunset around 8 p.m. and the free tickets are on the website, just above the donate button, in case
Awesome.
anyone's wondering. We also have the Astronomer in Residence starting
Yes.
up next month. So
Yay.
hooray! Blog sites will be coming up, and astronomers will be going out to Killarney Provincial Park. So if you are going camping out there, you can check the schedule to see when astronomers will be around to do
Mm-hmm.
tours. And of course, you can follow along with all the wonderful blogs. Julie, you know anyone who's going?
I know myself. I'm looking at the
Excellent.
schedule and I actually know many people on this schedule. I
Excellent.
also see
Excellent.
there are blanks. So if there are any astronomers out there who would like to apply.
Yes, it's a wonderful program, beautiful border class, clear dark skies, and of course we have free lodging for all of our astronomers. If you're not an astronomer, we can't promise you anything, but other than beautiful skies and astronomy
Yes.
tours.
Yeah. If you're not an
Uh,
astronomer, book a campsite. If you
Book a
are an
campsite
astronomer,
or a yurt. I hear the yurts are really nice, actually. But
yeah,
yes,
yurts are cool.
if you are an astronomer, you get
You
the
get the
apartment.
apartment, which is
The,
right behind the observatory.
oh, it's so nice. It's so
Oh, it's so
nice.
fabulous.
It's not even camping. It's like it's
Oh,
basically
no, not at all.
I'm pretty sure that's what glamping is, right? Just a shower and a nice place to stay and clear skies.
Yeah. It's my favorite week of the summer.
Mine too.
Yeah.
Although mine is different than yours because I go on a different week, but that's
Yes.
Anyways, Astronomer in Residence starting next month. Very, very fun for everyone involved. We encourage everybody to join in and follow along on the blog site or come and see us there. We will be live streaming from the site at least once or twice over the summer. So you
Nice.
can also look for us on YouTube.
Amazing. All right. Let's do some news.
News items. There's so much news going on. You've got a really cool one. Do you want to do yours first or mine first?
Now do yours.
All right.
It says
So
eclipse there.
eclipse. The eclipse happened. Oh my gosh, it was insane. The eclipse was amazing. I drove and drove and drove until I saw clear skies, and then I saw it.
Nice.
So that was fun. But the eclipse is still generating actually science, believe it or not. So the eclipse is okay. So in case anyone's listening and doesn't know that there was an eclipse in North America on April 8th. And in some places, in Ontario and not too far from Toronto, but not in Toronto, there was the path of totality. And during a total solar eclipse, the light from the sun is blocked, which means you get a fabulous view of the sun's corona and sometimes solar flares and prominences. And this April 8th, we got to see everything. It was awesome.
Oh,
And
I
everyone
got to see
from,
clouds.
oh, sorry.
No, but I did get to see. I got a peek. There were good. There were enough sucker holes,
Yes,
so I didn't get to see nothing.
and there are beautiful pictures
Yes.
on the Allan Carswell website. For the eclipse, we had two bloggers who've been putting up their eclipse pictures, Robin Metcalf and Bruce Waters, and we'll have a photo gallery from our crew as well, from everybody who was able to make it into totality or just for cool partial pictures. But if you were in totality with clear skies, the light is totally blocked from the sun, and you can actually see with your eyeballs awesome things like flares, prominences, and the corona. And this is where the news comes in because there was actually science happening during this eclipse. And of course, the eclipse path went through Mexico, the US, and through Canada. But there was a group of researchers led by the Southwest Research Institute that actually were chasing this eclipse by land and air,
Nice.
following this total eclipse path, collecting solar data from the total eclipse. So during totality, and they're watching the corona, the outermost atmosphere of the sun. And this was this experiment engaged over 200 community participants. They tried to make it an inclusive event. I believe somewhere there is a 60-minute high resolution movie. I haven't been
Ooh.
able to find the movie yet, but if you do look for it, I guess reply in the comments that you found it and tell us what the link is. But this was at the same time that there was a simultaneous investigation using NASA's WB 57F research aircraft, which is a very cool
Ooh.
craft, to chase the eclipse shadow, making observations from its flight, so up in the air, only accessible from a bird's eye view, and flying under that totality to get as long as possible um, observations of the solar corona. So a
Nice.
lot of complex and dynamic features are in the sun's outer atmosphere, and we don't have great views of that most of the time, especially here on Earth. We do have a couple really cool solar telescopes, but the faint light of the corona, despite it being incredibly hot, is usually vastly overpowered by the intense brightness of the sun. So this is not something that you would be able to see outside of a total solar eclipse path. And so between the citizen scientists and the bucket brigade of small telescopes following the eclipse path cross country and the airplane flying overhead, they were able to observe the corona and combine all of these different observations to look at it in new wavelengths with polarization measurements, try to understand the magnetic field, and of course this underlying mystery of why the corona is so hot. It's been a mystery since we've known about it. So this is amazing and super fun, and I love it. And I hope everybody does find that video and links it in here because this is my favorite news story of the day.
Nice. Oh my goodness. Can you imagine being the pilot of that airplane?
Oh my gosh, I know, right? I know. So much fun. So it just takes eclipse chasing to a whole nother level.
It's
Uh,
literally chasing.
Literally chasing. Exactly,
Love it.
exactly.
Love
That's how you
it.
do it.
Sign
Get
me
in.
up.
I know, I know, right? Speaking of things going black, I think we have time for
Yes, let's do it.
one more story.
All right. The most massive stellar black hole in our galaxy yet has been
Woohoo!
found, right? Okay. So, a stellar black hole is one that's formed from a collapsing star, um, not to be confused with the supermassive black hole that's in the center of our galaxy. So, this is the most massive stellar black hole yet to be discovered in the Milky Way galaxy, and it was found in data from ESA's Gaia mission. And it was found because it has a companion star that's orbiting it, and it made that star appear to wobble. So very much, very similar to um, the wobble way of finding um, planets.
Yes.
So the European Southern Observatory is a very large telescope. The Mercator telescope operated at La Palma in Spain, and the Observatoire de Haute-Provence were used to verify the mass of the black hole at 33 solar masses. So it's 33 times the mass of our sun. Stellar black holes are formed when massive stars die and their cores collapse. And previous discovered stellar black holes, previously discovered stellar black holes average about 10 solar masses. And the largest one previously known, Cygnus X1, is 21 solar masses. So this 33 solar mass one is huge. And this newly discovered black hole is called Gaia BH3, or BH3 for short. And it is in the constellation Aquila and is about 2,000 light years from Earth. So it's the second closest to us of the known black holes.
Very,
Uh,
very cool.
right? It was found while the team was reviewing Gaia observations for an upcoming data release. And the follow up observations revealed key properties of the companion star, which, together with the Gaia data, allowed the astronomers to precisely measure the mass of BH3. Similar black holes have been found in other galaxies using different observation methods, and astronomers theorize that they may form from the collapse of stars with very few elements heavier than hydrogen or helium, in their chemical composition. And because astronomers are quirky, everything heavier than helium is referred to as metal. So these stars are referred to as low metal or metal poor stars. So these stars are thought to lose mass lose less mass over the lifetimes and hence have more material left over to produce high mass black holes after their death. But there was very little evidence directly linking metal poor stars to high mass black holes. But this observation is some evidence for this. So the stars in pairs tend to have similar compositions. And so if we know the composition of BH3's companion, then we will know what the star that formed BH3 was likely made of. And the VLT data showed that BH3's companion was a metal poor star. So it's very likely that the star that formed BH3 was also metal poor, which agrees with the theory. And further observations could reveal more about the system and its history. Yay, black
Awesome.
holes.
This is such a cool one, and I just have to say we're gonna go just 1 minute over because this system is one of the coolest sci-fi systems I have ever seen because you've got this very quite, I mean, it's not a supermassive black hole, but it's a pretty massive black hole, 30, 32, 33, anything like that. And it's being orbited by a metal poor star with a distance from 4.5 to 29 AU, astronomical units.
Good Lord, that's
And
close.
imagine you're on a planet around that low metallicity star. Imagine how cool would that be? I want to see that sci-fi show. This is just I love binary systems because they just do the most amazing stuff. This
Yes.
is a great one.
I totally want to see that sci-fi show. Let's
Let's write
watch it
that.
together. Let's write it together.
Yeah, let's write it and become millionaires. Oh,
Oh,
awesome.
amazing. All right, everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Julie Tomei. You can always connect with us on Twitter or X at York Universe, on Instagram at York U Observatory, and on Facebook at Allan I Carswell Ops. Check out our website for content at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.
Clear skies, everyone.